Hi, everybody. My name is Skylar Storms. Today is August 3rd of 2025, and today I'm going to be going over gene sequence and mapping in a demonstration. So first we look at our given data. In our given data, we first can calculate what the total sum of the values are going to come to, which is 5,742, which will be used later when we're calculating our percent ratios. Our next step that we want to do is to actually sort out our data into the values that are closest together. For example, in the first one here, we have 1,340 and 1,362. Those are very close together, which is why I highlighted them in yellow. Our next values that are close together are 400 and 420, and the next ones are 100, 140, and then 970 and 1,010. So now that our data has been kind of paired, we can look at it in this form, which is a little bit different, which is our groupings. And then we also calculated our total for each of our groupings. And we also from there can assign our types of crossover categories as well. So for our highest value, we're going to have non-crossover. And then for our next two higher values, because it kind of goes in a decreased form, is going to be our single crossovers. And then for our lowest value, we will have a double crossover. And that is kind of how you sort those into a category after you group them together. Once we have all of that data, we now need to look at the possibilities so we can find the appropriate arrangement. And this can be seen in our possibilities over here. So we have ABC, ACB, and BAC. The differences are which values are on the outside or flank, and then the other difference is which ones are going to stay fixed in the center. The first one is B, the second one is C, and the third one is A. So we need to compare our possibilities to our double crossover. And this grouping over here shows that the bottom here is A++. So when we're doing a double crossover, for possibility number one, it's going to be like this, which is going to show plus B plus, but we need an A, not a B. So we can assume that this is not the correct one. When we look at possibility number two, we get plus C plus after double crossover, which is still not the right one. But if we look at possibility number three, we get plus A plus, and that seems appropriate. So from there, we can assume that A needs to be in the center when we're rearranging our groupings. So once those are rearranged, we get what looks like this in gene arrangement, because A is in the center of each of these. Now, this does not affect what our sums are of each grouping or what our type of crossover category is. It only changes how the letters of the genes are arranged. Now, we will calculate the distance between each gene. So using our gene arrangement values, along with our total sum of all of the values, we can calculate what our percent ratio of each grouping will be. And we do this by taking the total of each data set, so each grouping, and we will then divide that by the entire total of the data, which was at 5,742. And then we'll multiply that by 100 to get a percentage, which you can see here in the next couple of steps done for each one. Now, from here, a way to double check yourself is to take these percentages and add them together to see if you get 100. If you do, then great, you have done it appropriately. If your value is less than or greater than 100, then there may be an error somewhere, and I would go ahead and double check that your work is correct at this point before moving forward. From here, we now need to figure out which letters are going to which ones. Well, we know A is in the center. So when we're looking at our single crossovers in our two here, we need to find A to C and B to A. And that can be seen right here when we find our distance of A to C we need to take our percent ratio value and we're going to add that to the double crossover value that we got. And that's going to give 38.7 map units. And then we do the same thing for B to A, which is going to be that percent ratio we got for the third data set, plus the 4.2, and we got 18.5. Now this can be represented in a line form, which can be seen here, where we get B to A is 18.5. And from A to C, we have 38.7 map units. And this is a wonderful visual representation of the distance between the genes. Now that we have our genes in sequencing and we also have figured out what our map units and the distance between the genes are, we can then calculate our coefficient of coincidence, C, or interference, I. In order to do so, we have to convert our values back to decimal point form, which you can see here. So map units back to our decimal point form for each of our distances. And then we also have to put our actual double crossover percentage back to decimal point form as well, because we need all three of those values. In order to find the coefficient of coincidence, we also need the double crossover expected value as well as the actual. And in order to calculate that, we actually multiply our decimal form of our map units and distance in together, and then we get 0.072 or 7.2%, but we're going to use the decimal form for further evaluation. Now that we have that, we can calculate our coefficient of coincidence. And this is the actual divided by the expected value. So it's going to be 0.042 divided by 0.072, which will give us a coefficient of coincidence of 0.583. Now this value is used to calculate our interference, or I, as well. And here it's going to be our interference equals 1 minus the coefficient of coincidence, or 1 minus 0.583. And that interference gives us a value of 0.417, which will then convert to 41.7%. And that leads us to our conclusion. So we already can see that our 7.2% is higher than our 4.2% that we had for our actual value. So this can kind of help us infer and see, even down here when we calculated our interference, that we have a positive and not a negative interference. So in conclusion, there is a positive interference of 41.7%, meaning there are fewer double crossover events than we expected. And we could see that with our double crossover expected value compared to the actual. That is it for my presentation. Thank you all so much for watching, and I hope you have a great rest of your day. Thank you.